Greetings everyone. Today I, Nandini Tewari, will be opposing Chandranshu Nag's problem number 6, non-contact resistance. This is my video for round 3 of INYPT 2024. The structure of this opposition presentation is divided into 3 parts. The first one is the summary. This is essentially all that I understood from Chandranshu Nag's presentation and his explanation in his video. Secondly, we'll be moving on to his strengths. These are points that I found were detailed and were elaborated to a great extent. And lastly, we'll be coming to areas for improvement. These are sections with loopholes and a potential to be improved, and I will also be giving my insights on a few things which I feel could be done in a better way. Now, before we move on, let us firstly look at the problem statement for problem number 6 of INYPT 2024. The problem is, and I quote, "The responses of an LRC circuit driven by an AC source can be changed by inserting either a non-magnetic metal rod or a ferromagnetic rod into the inductor coil. How can we obtain the magnetic and electric properties of the inserted rod from the circuit's responses?" So from what I understand, when a non-magnetic metal rod or a ferromagnetic rod is inserted in the inductor coil of an LRC circuit, the responses of it change. So the problem statement here asks us to obtain the magnetic and electric properties of the inserted rod from the changed responses of the circuit. So the fact that the responses will change is already given to us, and it has already been established by the problem statement, and that is not to be disputed. What we have to do as experimentalists is to understand and derive the magnetic and electric properties of the inserted rod from the changed responses of the circuit. Now let us move to the summary. The summary of what I understood from Chandranshu's PPT and his video are divided into mainly 2 points. The first one was that he heavily elaborated and focused on the approximate change in the voltage estimated upon the introduction of a ferromagnetic and a non-magnetic core. And secondly, he distinguished metals based on the voltage increase upon the introduction of these two cores. So the main focus in his study was on voltage. Now as we move to the strengths, first of all, we talk about the good explanation of the core materials. The basic definition and properties of non-magnetic and ferromagnetic materials is provided at the very beginning, along with the non-magnetic and ferromagnetic materials used by Chandranshu in his experiment. Secondly, we come to the clearly followed methodology. The procedure was listed stepwise for a clear understanding of what is happening in the experiment and in the circuit. Thirdly, the resistance caused by inductors was also accounted for, since it was established that in real circuits, perfect inductors do not exist. Fourth of all, the theory of the working of inductors and capacitors was explained very well, and it was also told that both of them have an opposing effect on each other and on the current, voltage, and phase changes. Lastly, we come to the calculation of impedance. While the derivation of impedance wasn't listed, the formula was explained well. Now we come to the areas for improvement. The areas for improvement are as follows. First of all, certain guesses were made for the factor by which the inductance will increase. Even though the formula to calculate the inductance and the change in inductance was derived and mentioned, it was never actually used to calculate the values. Instead, only vague estimations were predicted, which may lead to inaccurate conclusions. Secondly, no quantitative calculations were done, except just the stating of the formula. No arithmetic and mathematical answers were also given, and only qualitative analysis was done, which does not provide a precise conclusion. Thirdly, there was poor experimental control, and there was also a gap in test. This can be proved by the fact that significant changes were only observed upon introducing ferromagnetic material and no change was observed upon introducing a non-magnetic core, even though it has already been established in the 6th IYPT problem statement that a change in circuit will be observed in the case of both a ferromagnetic and a non-magnetic material. Therefore, when his readings showed that the voltage in the case of an aluminium core, which was the non-magnetic material that he used, and in the case of no material in the inductor will both be equal to 0.8 volts, it tells us that the experiment had some fault. Fourth of all, the problem statement asked for both the magnetic and the electrical properties of the non-magnetic and ferromagnetic cores by analyzing the changes observed in the LCR circuit. But one part of the problem statement was completely ignored. Electrical properties of the non-magnetic and ferromagnetic cores were not talked about and mentioned at all. Fifth point, the reaction of the circuit to the non-magnetic and ferromagnetic cores was also not fully analyzed. Firstly, change in current was never calculated. Secondly, the magnetic properties were also not derived and only the approximate change in voltage was estimated, and a method to distinguish between non-magnetic and ferromagnetic materials from the change in voltage was discussed. Hence, in a nutshell, out of the two parts of the problem statement, the first part about electrical properties was totally ignored. And the second part, which was about the magnetic properties, was also not derived. Instead, an entirely third answer, which was the method to distinguish between the two materials using voltage, was discussed, something which wasn't even a part of the problem statement, and something which wasn't even asked for. The sixth point is that the first further optimization was stated incorrectly on slide number 20, or if you look for it in the video, it can be found at 10 minutes 9 seconds. The first further optimization was, and I quote, using a function generator instead of the direct AC source to generate a higher frequency sine wave. But the problem statement clearly states that the response of an LCR circuit which is driven by an AC source is to be investigated. Therefore, the optimization is inaccurate because using a function generator would completely change the experiment and contradict the basis of the problem statement. Seventh, Kirchhoff's laws were not mentioned. Current as a whole was not discussed in the entire presentation as already mentioned before, and hence Kirchhoff's current law was never brought up. But voltage, even after being so heavily focused on, did not once mention Kirchhoff's voltage law, even though these laws are crucial for LRC circuits in series. And lastly, spelling and typing errors were very heavily present. Even though they don't directly affect the reading and mathematical data and findings, they do hinder the process of presenting and understanding data. This competition is all about presenting your research in a manner which is detail-oriented and neatly presented, something which was missing from this presentation. Thank you so much.